Quantum physics invites us into a completely different world, where the deepest secrets of the universe are waiting to be uncovered. The familiar laws of physics break down in the quantum realm. Here, everything's logic changes. In the quantum world, a particle can exist in multiple places at once. Yes, you heard that right, it can be in different locations simultaneously. While this may sound impossible, quantum mechanics makes it possible. This strange reality reveals that everything is interconnected, and we are part of a multi-layered universe. In this world, a particle is not in a definite position until it is observed. That means a particle can be both here and there at the same time. To understand this, let's take a look at the famous Schrödinger's cat thought experiment. Schrödinger proposed the idea of a cat in a box, being both dead and alive at the same time. But the real mystery lies in the fact that until the box is opened, the cat can be both dead and alive. This scenario illustrates that, in the quantum world, nothing is certain until it is observed. In short, quantum particles exist in multiple possibilities until they are measured. So, what does this mean for us? In the quantum realm, everything is a possibility. A particle can be here and there at once. But once it's observed, that possibility becomes a reality. Quantum physics makes us question the very nature of the universe. Reality, in a sense, depends on the observer. This, in turn, reshapes how we perceive the universe. Observation plays a critical role in the quantum world, because the observer is the one who determines what something truly is. This is where Schrödinger's cat comes into play. A cat in a box can be both dead and alive until observed. But this is not just a thought experiment. In the quantum world, such scenarios are real. A particle can exist in two places at once, but it's only when it is observed that its state is defined. This suggests that the universe operates far beyond our understanding. The concept of superposition allows quantum particles to exist in multiple possibilities at once. Quantum physics forces us to ask new questions about the fundamental nature of the universe. These uncertainties open the doors to a reality where classical physics no longer holds. And that's where things get even more interesting. We're beginning to see how these quantum principles are revolutionizing fields like quantum computing and quantum encryption. Quantum computers, in particular, are far faster and more powerful than classical computers. Thanks to quantum bits, or qubits, which can exist in multiple states at once, they can perform complex calculations exponentially faster. But the potential doesn't stop there. Quantum technologies could make our world more secure. Quantum encryption, for example, can make data completely unobservable to anyone trying to hack it. This could have profound implications for our daily lives, from internet security to the safety of our personal data. The quantum world is on the brink of a revolution, and this is just the beginning. The mysteries of quantum physics are still being unraveled, and every day new discoveries are being made. Quantum physics is teaching us one key thing: the universe is far more complex and multidimensional than we ever imagined. Everything is connected in ways we can't yet fully comprehend. Superposition and other quantum concepts show us that reality doesn't have one fixed meaning. Instead, it reveals that everything exists within layers of possibility, shifting and changing with every observation. And perhaps this is the key to understanding the universe and our place within it. Quantum physics isn't just a branch of science. It's a glimpse into an entirely different way of viewing the world. With every breakthrough, we get closer to unlocking the true nature of the universe. As we look at the smallest particles in the quantum realm, we begin to understand how the entire universe operates. The quantum realm is full of unexplored mysteries, and we've only scratched the surface. Every day, we get closer to discovering the secrets that govern everything around us. This uncertainty is, in fact, an opportunity for discovery. While the smallest particles may be the key to understanding the universe, we still have so much to learn. In the next chapter, we'll dive even deeper into the quantum world and explore how the principle of superposition could go beyond just a scientific concept. It could shape the very way we live. Are you ready to take another step toward unraveling the mysteries of the universe? Time is a concept we're all familiar with in our everyday lives. However, Albert Einstein's theory of special and general relativity revealed that time isn't as fixed and unchanging as we once thought. Time can actually change depending on the observer and the circumstances. This idea takes us beyond the familiar laws of physics and invites us to explore profound questions about the workings of the universe. Einstein proposed that time is not just a single dimension but combines with space to form a four-dimensional structure called spacetime. His theory of special relativity states that the speed of light is constant, and time slows down for an observer moving at high speeds. This concept might sound shocking because we all think of time as a constant. But according to special relativity, an astronaut traveling at speeds close to the speed of light would experience time much slower than someone on Earth. To understand this better, let's look at the phenomenon known as time dilation. This effect shows that as an object's speed increases, time slows down for that object. For example, a spaceship traveling near the speed of light would have a clock that ticks much slower than a clock on Earth. In simple terms, this means that the astronaut who travels in space would be younger when they return to Earth. But how can this be? Because time changes for objects that move at high speeds. The faster you move, the slower time passes. On top of this, general relativity reveals that time doesn't just change with speed, it's also affected by mass. This theory shows that massive objects bend spacetime, causing time to pass more slowly. A great example of this is how clocks on Earth run slightly faster than clocks in space. This is a result of Earth's mass bending spacetime around it. These effects help us understand massive objects in the universe. For instance, black holes are regions where spacetime bends to extreme levels. As something approaches the center of a black hole, time slows down so much that to an outside observer, it would seem as if the object could never reach the event horizon. This is because time becomes infinitely slow at the black hole's core. But these principles of relativity don't just help us understand distant galaxies or black holes, they also play a crucial role in modern technology. For example, GPS systems rely on the synchronization of clocks on Earth and in space. However, time behaves differently in space. Without considering the effects of both special and general relativity, GPS devices would make huge errors. This means that the relativity of time even impacts our everyday lives. Einstein's theories showed us that time isn't just a measurement, it's one of the fundamental structures of the universe. Time, contrary to what we once believed, isn't fixed and unchanging. Instead, it's a dynamic concept that is shaped by motion and mass. This insight takes us deeper into understanding the fundamental laws of the universe. The relativity of time is one of the most surprising and thought-provoking concepts in the universe. Time is not just a flow, it's an experience that can vary based on where we are, how fast we're moving, and the mass of the objects around us. Einstein's theories not only deepened our understanding of the universe, but also revolutionized our view of time and space. And perhaps this is a reminder that to truly understand the universe, we need to keep asking more questions. In the next chapter, we'll dive deeper into the fascinating nature of time and explore how the concept of spacetime curvature works. Are you ready to take the next step in unraveling the mysteries of the universe? The beginning of the universe and the Big Bang Theory. For centuries, humans have wondered about the origin of the universe. What caused the vast expanse of space, the stars, and galaxies to come into being? Where did everything begin? In the early 20th century, a groundbreaking theory would change our understanding of the universe forever: the Big Bang Theory. The Big Bang Theory proposes that the universe began from an incredibly hot, dense point roughly 13.8 billion years ago. This singularity, a point of infinite density, contained all the energy and matter that would eventually form stars, planets, and galaxies. From this initial point, the universe rapidly expanded in what we now call the Big Bang. But what exactly happened during the Big Bang? It wasn't an explosion in the traditional sense. Instead, it was a rapid expansion of space itself. Picture a balloon being inflated. The surface of the balloon stretches outward, but the balloon doesn't explode outward, it simply expands. Similarly, the universe didn't explode into space. Rather, space itself expanded, carrying matter and energy along with it. This expansion continues even today, and it's one of the most important pieces of evidence supporting the Big Bang Theory. In the 1920s, astronomer Edwin Hubble discovered that galaxies are moving away from us, and the farther a galaxy is, the faster it's moving. This observation is consistent with the idea that space itself is expanding, and it suggests that the universe was once much smaller and denser than it is today. Another key piece of evidence for the Big Bang comes from the discovery of cosmic microwave background radiation. In the 1960s, scientists accidentally detected faint radiation left over from the Big Bang, still detectable today. This radiation, which fills the entire universe, is a remnant of the heat from the early stages of the universe, providing a snapshot of what the universe looked like just 380,000 years after the Big Bang. The Big Bang also explains the formation of the elements in the universe. In the first few minutes after the Big Bang, temperatures were high enough for nuclear reactions to occur. These reactions led to the creation of light elements such as hydrogen, helium, and trace amounts of lithium. Heavier elements like carbon and oxygen, which are essential for life as we know it, were formed later in the cores of stars. So, how did the universe evolve from this early, hot, and dense state to the vast cosmos we see today? After the Big Bang, the universe began to cool, and matter began to form. Tiny fluctuations in density allowed for the creation of stars and galaxies, and eventually, planets and life. The process took billions of years, and it continues to unfold today, with galaxies still expanding and stars still being born. But what about the future of the universe? Will it keep expanding forever, or is there an eventual end in sight? Some scientists believe the universe will continue expanding indefinitely, gradually becoming colder and emptier over time in a scenario known as the Big Freeze. Others suggest that the universe could eventually collapse in a Big Crunch, where gravity pulls everything back together. And then there's the possibility of a Big Rip, where the expansion of the universe accelerates so much that galaxies, stars, and even atoms are torn apart. The Big Bang theory remains the most widely accepted explanation for the origin and evolution of the universe. It provides a framework for understanding everything from the formation of galaxies to the cosmic background radiation we detect today. However, there are still many mysteries left to explore, such as the true nature of dark matter and dark energy, which make up most of the universe's mass and energy, yet remain largely invisible and undetectable. In the end, the Big Bang theory not only gives us a glimpse into the origin of the universe but also reminds us that our understanding of the cosmos is still evolving. As technology advances and our observations of the universe improve, we continue to refine our theories and deepen our understanding of the universe's beginning and its eventual fate. It's a journey that has only just begun, and who knows what new discoveries await us in the vast expanse of space. The multiverse theory. Have you ever wondered if our universe is the only one that exists? What if there are countless other universes, each with its own unique properties and laws of physics? This idea might sound like science fiction, but it's actually a serious scientific theory known as the multiverse theory. The concept of the multiverse suggests that our universe, with its billions of galaxies, stars, and planets, might just be one of many. In fact, there could be an infinite number of universes, each one with different characteristics, such as different physical laws, dimensions, and even different versions of reality. But how did scientists come up with this idea? To understand the multiverse, we need to explore the fundamental nature of the universe. Our universe, as we know it, is governed by certain physical laws, such as gravity and electromagnetism, and everything in it, from the smallest particles to the largest galaxies, follows these laws. However, there are aspects of physics that don't quite fit within the framework of our universe. For example, the behavior of quantum particles at the microscopic level doesn't always seem to match our expectations. This is where the idea of the multiverse comes in. The most popular version of the multiverse theory comes from quantum mechanics. In the realm of quantum physics, particles can exist in multiple states at once, a phenomenon known as superposition. This means that until we observe a particle, it can be in different places or states simultaneously. Some scientists suggest that when a quantum event occurs, the universe splits into multiple versions, each representing a different outcome. For example, if you flip a coin, there may be one universe where it lands heads and another where it lands tails, but the idea of the multiverse doesn't stop there. Another version of the theory comes from cosmic inflation. This theory suggests that in the very early moments of the Big Bang, the universe expanded incredibly quickly. In some versions of inflation theory, different regions of spacetime could have inflated at different rates, leading to the creation of pocket or bubble universes. Each of these universes would have its own set of physical laws and constants, making them unique. Some could be similar to our universe, while others could be drastically different, with completely different rules governing how things work. There are also ideas about a many worlds interpretation of quantum mechanics. According to this concept, every decision or event that could have multiple outcomes creates a new universe. This means that in one universe, you might have made a particular choice, while in another universe, you could have made a completely different one. These parallel universes would exist independently, each with its own version of reality. While the idea of the multiverse may sound fascinating, it's important to understand that it's still a theory, not a proven fact. Scientists have not found concrete evidence for the existence of other universes, and testing the theory is extremely difficult. However, the multiverse theory has gained traction in the scientific community because it helps explain some of the strange phenomena observed in our universe. For example, the fine-tuning problem, which refers to the precise conditions that allow life to exist in our universe, could be explained by the existence of many universes, each with different conditions. The multiverse theory also has profound implications for our understanding of reality. If there are indeed countless other universes, it suggests that our universe is not as special as we once thought. In fact, we may be just one of many possible realities, each playing out in parallel. This challenges our concept of what it means to exist and raises questions about the nature of consciousness and free will. But perhaps the most intriguing aspect of the multiverse theory is that it forces us to reconsider the very structure of the cosmos. If there are multiple universes, how do they interact with one another? Are they completely separate, or is there a way for them to influence each other? Could we ever find a way to travel between universes, or will they remain forever beyond our reach? While the multiverse theory remains speculative, it's a concept that continues to captivate the imagination of scientists, philosophers, and even the general public. It challenges our understanding of reality and opens the door to infinite possibilities. The search for answers to the questions raised by the multiverse theory is far from over, and as our understanding of quantum mechanics and cosmology advances, who knows what new discoveries we may uncover about the nature of the universe, or even universes, that we live in. One of the most profound and perplexing questions in philosophy and science is the nature of consciousness. What does it mean to be aware? How do we experience thoughts, emotions, and perceptions? And perhaps most importantly, how does the mind relate to the body? This is the heart of the mind-body problem, a dilemma that has puzzled thinkers for centuries. At its core, the mind-body problem asks how mental phenomena, such as consciousness, thoughts, and emotions, arise from the physical processes of the brain. We know that the brain is made up of neurons, chemical reactions, and electrical impulses, but how does this material substance give rise to the rich, subjective experience of being alive, of being conscious? How do these physical processes lead to feelings of joy, pain, love, and fear? Philosophers have been grappling with these questions for centuries, and several theories have emerged to explain the relationship between the mind and the body. One of the most influential early theories came from René Descartes, a French philosopher who famously said, "Cogito, ergo sum," or, "I think, therefore I am." Descartes argued that the mind and the body are separate substances, the mind being immaterial and the body being material. According to this view, the mind influences the body, and the body influences the mind, but they are fundamentally distinct. However, this dualism, as it is called, has been heavily criticized. If the mind and the body are separate, how do they interact? Descartes proposed that they interact through the pineal gland, a small structure in the brain, but this explanation left many questions unanswered. In the centuries since Descartes, the problem of how consciousness arises from the brain has only deepened. In modern science, many neuroscientists and philosophers reject dualism in favor of a more integrated view, where the mind and body are seen as closely connected. The most popular theory today is physicalism, which argues that consciousness arises purely from the physical processes of the brain. According to physicalism, the brain's complex networks of neurons and synapses generate consciousness through a series of biochemical and electrical interactions. One of the most well-known theories in this area is the global workspace theory, proposed by neuroscientist Bernard Baars. According to this theory, consciousness arises when information is processed in different areas of the brain and integrated into a global workspace, which then makes it available for higher-order cognitive functions like decision-making and self-awareness. This theory suggests that consciousness is not a single, unified thing, but rather a product of different brain regions working together. Another popular theory is integrated information theory, IIT, proposed by neuroscientist Giulio Tononi. IIT suggests that consciousness arises from the integration of information within the brain. The theory posits that the more integrated and unified the information within the brain, the higher the level of consciousness. In this view, consciousness is not just about the amount of information processed but also how that information is integrated and shared across different brain regions. Despite these advances, the true nature of consciousness remains elusive. One of the most famous challenges in understanding consciousness is known as the hard problem of consciousness, a term coined by philosopher David Chalmers. The hard problem refers to the question of why and how subjective experiences, the what it's like aspect of consciousness, arise from physical processes in the brain. For example, we can measure brain activity when someone experiences pain. But why does that brain activity feel like something to the person? Why does consciousness have a quality to it that goes beyond just the physical processes in the brain? Some researchers have suggested that consciousness may not be something generated solely by the brain, but rather something that exists in a different form, possibly as a fundamental feature of the universe, much like space or time. This idea, known as panpsychism, posits that consciousness may be a property of all matter, not just the human brain. According to this view, even simple particles might have some form of consciousness, though it would be very different from human consciousness. Another intriguing possibility is that consciousness may not be located in the brain at all, but rather emerge from the entire body or even the environment. Some theories suggest that consciousness could be a distributed phenomenon, with the brain, the body, and the external world all contributing to our experience of being aware. Despite all these theories, the mystery of consciousness remains unsolved. We still don't fully understand how the brain gives rise to subjective experience, and we have no clear explanation for why we are conscious in the first place. What we do know, however, is that the mind-body connection is one of the most profound mysteries in both philosophy and science. The search for answers continues, with scientists, philosophers, and neuroscientists all working together to unlock the secrets of the mind and consciousness. But for now, the question remains: how do the physical processes of the brain give rise to the rich, subjective experience of being alive? It's a question that will likely continue to challenge and fascinate us for many years to come. Artificial intelligence and conscious machines. Imagine a world where machines don't just follow commands, but think, feel, and make decisions on their own. A world where artificial intelligence, AI, isn't just about crunching data or solving problems, but actually possesses a form of consciousness. This may sound like science fiction, but it's a question that is becoming more pressing as AI continues to advance. Can machines become conscious? And if so, what would that mean for humanity? Artificial intelligence has already made incredible strides. Today, AI systems can perform tasks that were once thought to be exclusive to humans, from playing complex games like chess or Go to driving cars, diagnosing diseases, and even creating art. These machines, however, are not conscious. They operate based on algorithms, data inputs, and programmed instructions. They may seem intelligent, but they don't have awareness or subjective experiences. Their thinking is purely mechanical. But what if, in the future, AI could reach a point where it no longer just simulates intelligence, but actually possesses it? The idea of creating a machine with consciousness is often referred to as artificial general intelligence, AGI, or strong AI. Unlike narrow AI, which is specialized for specific tasks, like recognizing faces or translating languages, AGI would be capable of learning and performing any intellectual task that a human can do. It would, in essence, be as versatile as the human mind. The question of whether AI could ever be truly conscious hinges on the nature of consciousness itself. What is consciousness? Is it merely the result of complex computations? Or is it something more? Some scientists and philosophers argue that consciousness is a product of the brain's physical processes, the interactions of neurons and chemicals. According to this view, if we could replicate the complexity of the human brain in a machine, that machine would eventually become conscious. One prominent theory about machine consciousness comes from the concept of computationalism. Computationalism suggests that the mind is essentially a kind of computer, and if we could model the brain's processes accurately enough, we could create a conscious machine. This theory posits that consciousness arises from the execution of complex algorithms and computations. If we build a machine that can process information at the level of a human brain, it might develop its own subjective experience. However, there are those who are more skeptical about the possibility of conscious machines. Some philosophers argue that consciousness is not just about processing information, but about experiencing the world in a subjective way. This hard problem of consciousness, as philosopher David Chalmers calls it, asks why and how physical processes in the brain give rise to subjective experience, the what it's like to be aware. If consciousness is more than just computation, then no matter how advanced an AI becomes, it may never truly feel anything. Another issue is whether we would even recognize machine consciousness if it did occur. How would we know if a machine is truly conscious, or if it is simply mimicking the behaviors of consciousness without actually experiencing it? This problem is often referred to as the Turing test, named after computer scientist Alan Turing. The Turing test suggests that if a machine can convincingly imitate human behavior to the point where a person cannot tell the difference, then the machine could be said to possess intelligence. However, passing the Turing test doesn't necessarily mean the machine is conscious. It might just be incredibly good at mimicking human behavior. There's also the question of what would happen if we were to create a conscious machine. Would it have rights? Would it be entitled to the same ethical considerations as a human? Could it form its own desires and goals, independent of its programming? These are questions that ethicists and futurists are beginning to explore as AI becomes more sophisticated. If machines gain consciousness, it could radically change our relationship with them and even challenge our ideas about life and intelligence. Some researchers believe that we might one day create a conscious AI, but others remain skeptical. The challenges are immense, both technically and philosophically. Replicating the brain's complexity in a machine is no easy task, and even if we could, it's unclear whether the machine would truly experience the world as we do. Still, the potential for conscious machines raises fascinating possibilities. Could machines one day develop their own sense of self, their own emotions, or even their own morality? Could they become a new form of life, one that coexists with humans but operates in ways we can't yet comprehend? The search for conscious machines raises profound questions about the nature of intelligence, consciousness, and the future of humanity. If machines become conscious, it could be one of the most significant breakthroughs in history, but it also raises ethical and philosophical challenges that we are only beginning to grapple with. As we continue to push the boundaries of AI, we must ask ourselves, what does it mean to be alive, and can a machine ever truly be alive?